In this video, we're going to look at some very basic ideas about exponents. So probably the 8th grade level math. At least that's what my granddaughter is doing right now in the 8th grade. But let's look at main definition, exponent. So I got a base. I'm going to call it b. And then the n over here is the exponent. So we can read this as b to the nth power, and the n is called an exponent. It can be called the power, and all this means is the base is taken as a factor n times. So I would write b, I won't put the dots here because it's understood to be multiplied b times b times b, and so on. And that's going to be n factors. So if this space had an exponent of 3, I could expand it and write 3 factors of b. b times b times b. If it was 5, I'd have b times b times b times b to 5 factors, and so on. Now the exponent could be negative, it could be a fraction. We're going to focus on where the exponent is a positive integer. So let's clear this. So let's look at some examples first with numbers. So suppose I have 2 to the 2nd power multiplied by 2 to the 3rd power. Now the first property or rule states if you're multiplying 2 bases that are the same, one's taken to the n power, the other one's taken to the n power, it says bring down the base and add the exponent. And now that makes sense because if I look at 2 to the 2nd, that means 2 factors of 2. If I look at 2 to the 3rd, that means 3 factors of 2. So I got 2 factors of 2 here, 3 factors of here, altogether I have 5. So 2 to the 2nd times 2 to the 3rd is 2 to the 5th. And if I multiply out 5 factors of 2, I should say, that would give me 32. Now obviously with numbers I could do it here. So, okay, well 2 to the 2nd, that means 2 factors of 2, 2 times 2, that's 4. And 2 to the 3rd, that means 3 factors of 2, so that's 2 times 2 times 2, that's 8. And then we do it 4 times 8 then. We could do it that way, and we still get 32. Okay, let's clear this. But if the base is a variable, then if I have x to the 4th power times, say, x to the 5th power, so we're multiplying powers of the same base. The first rule says, well, simply bring down the base, add the exponents. 4 and 5 is 9. Since we don't know what x is, we can't give a number, so we just leave it x to the 9th. We add the exponents because it's 4 factors of x multiplied with 5 factors of x. Altogether we have 9 factors. 4 and 5 is 9. Now let's look at something like this. Suppose we have x to the 4th power divided by x. So on top then, we want to simplify this. On top we have x to the 4th, that's 4 factors of x. In the bottom we have 1 factor of x. Now keep in mind that if the variable doesn't have an exponent, it's understood to be a 1. The coefficient, if it doesn't appear, it's understood to be a 1. So when I have just x, that means coefficient is 1, the exponent is 1. So here I have 4 factors of x over 1 factor of x. Well, obviously you can see you can cancel 1 factor from the numerator, 1 factor from the denominator. That leaves me with x to the 3rd then. I'll try one like this. You have x to the 10th. And the base at the bottom say is also an x. X to the 7th. See, how do you simplify this? Well, 10 factors of x on top, a numerator, 7 factors of x in the bottom. So you can cancel 7 with 7. So that's going to leave me with x to the third. And notice that's the same thing as 10 minus 7. 10 minus 7 gives me 3. And that's what the second property, or second rule, is telling you. If you're dividing powers or exponents of the same base, this tells you bring down the base and subtract the exponent. So the exponent in the numerator, it's minus the exponent in the denominator. So that's what you have here. If you look at this setup, this is going to be bring down the base, and it's 10 minus 7. And notice if I put it the other way around, say I write it x to the 7th over x to the 10th. Now let's look at it this way first. I got 7 factors of x in the numerator and 10 factors of x in the denominator. So I can cancel the 7 factors in the numerator. And when they divide out, those give me 1. So that just leaves you with a 1 on top. And then in the bottom, 7 factors canceled, 7 of the 10 factors in the bottom, that's x to the third. Well, notice, rule number 2 says if you're dividing powers of the same base, bring down the base. So if I follow the rule number 2 for this one, I would bring down the base. And then I would have, in this case, m would be 7 and n would be n. So this would be 7 minus 10. That would give me x to the negative 3. Now doing it this way, I got 1 over x to the third. So what does that say? That tells me that x to the negative 3 is the same thing as 1 over x to the third. So that you jump to this one here. That's what number 6 is telling you. If you have a to the negative n, exponent is a negative, that's going to be the same thing as 1 over a to the n. So that's your rule for this. Anytime you have a negative power. So whether it doesn't matter what the variable is, it could be a y. I have y to the negative 5. The exponent is negative. Another way to write this, according to rule number 6, is 1 over y to the 5th. Remember, this is understood to be over 1. That's over 1. So this goes both ways. So you have y to the negative 5. That's the same thing as 1 over y to the 5. Going back the other way, if you have this and you want to write it with a negative exponent, then this goes to the numerator, you change the sign. Same thing. So again, if you're multiplying powers of the same base, bring down the base, add the exponents. And we're focusing on exponents that are integers, but they could be positive integers, but they could be negative, they could be fractions, as we'll see a little bit later on. And then the second one again says if you're dividing powers of the same base, bring down the base and subtract the exponent. And it's always the numerator exponent minus the denominator exponent if you do it that way. Now, this is supposed to have something like this. I have x squared, that's an exponent. And say I have it in parentheses. I have it in parentheses. So let's see, one way to do this is to say, okay, the base in this case is x squared. No, that's the whole base. And that's taken to the third power. But the exponent up here means that this base is taken as a factor 3 times. So that's the same thing as x squared times x squared times x squared. And now we can use rule number 1. It doesn't matter if there's two factors that you're multiplying or 3 or 10. the rule is the same. If you're multiplying powers of the same base, as long as the base is the same, it's x, x, x. We bring down the base, add the exponents. So that's what? 2 plus 2 plus 2, that's 6. So this taken to that power is 6. Notice a shortcut to do this is anytime you have a power to a power, you multiply the exponents. That'd be 3 times 2 is 6. And that's what rule number 3 is telling you. If you have a to the m, parentheses taken to the n power, bring down the base and just multiply those exponents. So again, if you have y to the 7th taken to the 3rd power, well, let's just say to the 10th power. Instead of writing this 10 times as a factor and then adding the exponents, the shortcut is just to say, okay, that power to a power is 10 times 7. So this is y to the 70th power. That's your solution. Now for number 4, this is saying if you have a fraction taken to any power, that's the same thing as taking the numerator to that power and the denominator to that power. So let's do one like this. It's x squared. Say this is y to the 3rd. And let's put it in parentheses. The whole thing is taken to some power. Let's say 7. So according to rule number 4, that means if you have a fraction taken to any power, that's the same thing as taking the numerator to that power. So I can write this as x squared. Put it in parentheses. Taken to that power, 7. And then y to the 3rd. Taken to that same power. And then from here you can just use rule number 3. When you have a power to a power, this is x squared to the 7th. Y cubed to the 7th. Okay? Both of these are exponents. Just bring down your base. Multiply these powers. 2 times 7, that's 14. And then here, bring down the main base, which is y. Multiply the exponents. 3 times 7, that's 21. Now because the base here and the numerator and the denominator are different, that's as far as we can go. But if we had an x here, then we can go ahead and subtract exponents and reduce it. Say this was an x here. Say this was x. Obviously we could have reduced it first if it was an x. But then you can do the rules for division. But in this case, that's as far as we can go. The 5th one tells you that anytime you take a base to a 0 power, and this is with the condition that here a cannot be 0. Okay, not going to work for 0. But any number, whether it's a positive number or a negative number, and let's see why that works. Let's look at we'll do it with numbers. So let's look at 2 to the 4th divided by 2 to the 4th. Well, it's the same number divided by the same number, so you know that this is 1. Right? 2 to the 4th is 16. 2 to the 4th is 16. It's the same number, so we divide anything by itself. As long as we don't divide by 0, that's always going to come out to a 1. But now, if we follow the rule for number 1, or number 2, I should say, when you're dividing powers of the same base, bring down the base, subtract the exponents. So it's 4 minus 4 is 0. And of course, we got this equal to 1 already by just dividing these out. So that tells me then that 2 to the 0 equal to 1. And that's how rule number 5 is obtained. Any number to the 0 power is 1. Okay, number 6. Talked about this one already. And this is saying if you have any number to a negative power, that's going to be 1 over that same base with a positive power. So if you have 2 to the negative 3. Now 2 to the 3, if it's positive, that's 8. But if it's negative, it's 1 over 2 to the 3, which is 1 over 8. So that you can see this, let me set it up over here this way. So let's suppose, how do they come up with these roots? Well, 2 to the negative 3 equals to 1 over 8. We can do this. 2 to the negative 3, I'm going to write it as 2 to the negative 3 over 1. That's the same thing. You divide anything by itself by 1, it gives you the same thing back. So this is equal to this. Now I'm going to multiply the denominator by 2 to the 3. And I can do that as long as I do the same thing to the numerator. So multiplying by 2 to the 3rd up here. Because remember, all I'm doing is multiplying this thing by 1. 2 to the 3rd divided by 2 to the 3rd is 1. So it doesn't change it. So now this gives me 2 to the 3 and times 2 to the negative 3. We bring down the base at the exponents 3 and negative 3. This is 0. And 1 times 2 to the 3 is 2 to the 3. And of course, we just mentioned that any number to the 0 power is 1. So this is 1 over 2 to the 3, which of course is 8. Now this works also if you have it this way. So if you have 1 over, if you have, say, 1 over 3 to the negative 2, okay, doing the same sort of thing, you can justify this and say, so this is 1 over 3, and that's a negative 2 there. That would be the same thing as 3 to the positive 2. 1. And now 3 to the 2nd power is just 9. 9 over 1 is 9. So basically what we're saying, if you just have a single term, it's got a positive exponent, and it's in the numerator, take it to the denominator, change the sign. If it's in the denominator, and it's a single term like this, bring it up and change the sign, you get this. Now the last one gives you a relationship between fractional exponents and radicals. So this is saying that you have a to the 1 over n power. That's the same thing as the nth root of a. It's a to the 1/2. And let me write this so it's understood here. This would be the nth root of some number x. Okay. So it's the nth root. The n is called the index, and the x is called the radicand. And of course you have the radical symbol in the middle. That's your radical symbol. And then the index is n, and the radicand is x. In other words, the number or expression under the radical is the radicand. So if you have a to the 1/2, that's the same thing as the square root. Now, so this index here is 2. You don't write it in if it's a 2. If it's a square root, you leave it out. Okay. In other words, this is understood to be a 2 there, but we leave it out. If you have 8 to the 1/3, let's do numbers now. 8 to the 1/3. That's the same thing as the cube root of 8. Cube root of 8. So what is the cube root of 8? In other words, what can I multiply by itself? 3 factors of that same number to get 8. Well, 2 times 2 times 2 is 8. So the cube root of 8 is 2. Now another way to look at this, using some of the laws of exponents, is let me write 8 as 2 to the 3rd. Okay, 2 to the 3rd is 8. Now basically I have a power to a power to a power here. So the rule we looked at a while ago said power to a power, multiply the exponent. So bring down the base, and then it's 1/3 times 3. That's 1, or just 2. That's your answer. Now let's suppose we have 16 to the 1/4 power. That's the same thing. If I put that as a radical, That's the same thing as the fourth root of 16. And this is asking for the fourth root then. This is the fourth root, the 4. Now I wrote this. This one is really an exponential. We call this an exponential. And then we convert this to a radical. This is the radical associated with this. So what is the fourth root of 16? That means basically I want what number to the fourth power would give me 16. What number to the fourth power would give me 16? You can figure that out, but just again, just to show the relationship between what the properties over here of exponents. 16 is the same thing as 2 to the fourth, because 2 times 2 times 2 times 2, that's 16. And then if I take this to the 1/4 power, now I have it as a power to a power. That's another way. If you can't figure it out here, what number to the fourth power gives me 16, you can do it this way. 1/4 times 4, power to a power, multiply it, we'll get 1. So this gives me 2. Now let's look at something like this. Take it another step further here. X squared, 2x squared, y to the third, taken to the third power. So one other rule of exponents I could put there is this. If you have a product of 2, this works for 2, 3, as many factors as you want. If you have, say, a product of factors taken to an nth power, that's the same thing as taking, and I don't think this was included here. Let me check. Okay, that wasn't included here. But that's another rule for exponents. If you have a product of factors taken to a power, that's the same thing as taking each factor to that power. There you have it. A to the n, b to the n. Because that's what I'm going to use for this one. So in this case, I have 3 factors. So I have 2x to the second, y to the third, taken to the third power. Now I could write this out as a factor 3 times. I could put this once, twice, third time, and then multiply out the numbers, the coefficients. I'd have 3 factors, and each factor would have a 2. So it'd be 2 times 2 times 2, that would be 8. But following this rule here, this would be the same thing as just doing this, taking each of these factors to the third power. So I'm going to just say 2 to the third, x squared, to the third, y to the third, to the third. And then here I can just follow the rule. When you take something to a power, you multiply the exponents. So here, let me write it down here. So this is going to equal, let me write it over here. Let's do the variables first. X squared to the third, multiply the exponents. That's 3 times 2 is 6. So this will be x to the 6. Then this one, power to a power, multiply the exponents. 3 times 3, that's 9. This would be y to the 9th. Now one of the mistakes that a lot of students will make here is they're doing, okay, 3 times 2 is 6, 3 times 3 is 9, and then they'll go 3 times 2 and they'll put a 6 here. But notice here we're multiplying exponents. The 2 is not an exponent. The exponent on the 2 is understood to be a 1. So if you want to do it that way, it's 3 times 1. So that's 2 to the third, which is 8. Now there's negative exponents in there. It still applies. Now sometimes they're going to ask you to do something like this. They'll give you something like this. Say 4x to the negative 2 y times z to the second over, say, 2 say x to the third y to the negative 2 over z to the negative 5. And they'll say, simplify this. So they want you to write it, say, with just positive exponents. They don't want negative exponents. Now, as long as this is all multiplication, you can still follow the rules. Look, so let me do it this way. Look at the x's. Look at x to the negative 2 over x to the third. X to the negative 2 over x to the third. Subtract the exponents, that'd be x to the negative 2 minus 3. So let me do it this way. First the numbers, 4 divided by 2, that's just 2. Okay, bring down the base. And then here I would say negative 2 subtract 3, that's negative 5. I bring to the other base, y. Then remember the exponent on the y, it doesn't have one, it should be 1. So 1 subtract a negative 2. 1 subtract a negative 2. When you subtract a negative 2, it changes it to a positive, so that'll becomes a 2. 1 and 2 is 3. And then the next one, z and z. Okay, it's 2 subtract, bring down the base, that's z. 2 subtract a negative 5, that's a positive 5, so this would be 7. Okay, so just visualize it. It's all multiplication. Now you could do something. You couldn't do this kind of thing if there was a plus in between here. See, this is all multiplication. So I can just treat the 4 and the 2 as separate. 4 over 2 is 2. And then x to the negative 2, x to the third, subtract the exponents. That's applying the rules for exponents. Get negative 5. And then this is a 1 here for this one. 1 subtract negative 2, that's 3. Okay, we get this. And then for this one, 2 subtract negative 5 becomes a plus 5. 2 is 7. Now, this is actually the answer. But let's suppose they said, well, we don't want the answer with negative exponents, so this one has to go. So how do I make this a positive exponent? See, the others have a positive exponent already. So one way you can do it is just bring it to the denominator and change the sign. So this will become x to the fifth. And this would be your simplified answer. Again, these are operations with monomial type expressions. You can use these type of formulas for binomials, trinomials, and so forth. If you wanted to see more examples like this, leave a comment and let me know what you want to see involving exponents, and I'll put up another video. Again, this is pretty much 8th grade level math. So thanks for watching, and we'll see you next time.